All right, testing. All right, cool. That works. People are still coming in, so I'll just get started because we have a lot of stuff to go through today. Yeah, my name is Arjan Brussee. I'm a technical director at Epic Games on Unreal Engine, and I'm going to talk to you today about what's been happening in Unreal Engine and what's going to come up next. So we're going to go over like what's going to come in like 5.5 and future releases, and kind of as a first glimpse, because we haven't shared this broadly yet. So this is kind of one of the first showcases of like what's going to come in the next few releases. As a disclaimer, because we always want to do disclaimers, we generally want to under-promise and over-deliver, which means that in the past we've told you nothing, right? We always surprise you like, hey, new release, all kinds of cool stuff. But we kind of want to change that a bit and kind of tell you what we're working on, like where we're investing, so that you can make choices as well, like where you want to put your own efforts into the technology, for sure. So, but the plans are tentative, right? We're trying to release these things on this time frame, but it's development, like you all know, it will take sometimes longer. So yeah, let's start by just quickly reiterating the pillars of Unreal Engine 5. And really the aim for UE5 is to enable this generational leap in graphics fidelity, and also dynamics, supporting huge worlds seamlessly, with like faster workflows, improved workflows, but also making it a lot easier to use and extend. And we are hitting good strides on all of these areas, but we're not done, right? These are kind of the pillars for the entire development of the entire engine. So we'll keep hammering away at all these things. But it's also a dynamic plan, right? We will add new things when we see them come up. For instance, PGG was a big new feature that we introduced last year that we found while we're developing all these things and these demos. We had to kind of create different tools and add that to the list. So what I want to do, is it readable? There's a lot of bright light. It's really washed out. You don't know? Okay. If it's not readable, you should put up your hands so we can maybe do something about it. But okay. So what I want to do is like really quickly go through kind of the journey of it, right? Because the journey shows where we learned things and what we kind of developed. And really it started with this demo that was in 2020 already, crazy long time, where we really kind of used the new rendering ideas and the R&D and kind of showed it in kind of an early version of UE4 to kind of see what it could be like. It was running 30 hertz on the PlayStation 5. Then a year later, we took all these learnings from that previous demo and kind of we said like, okay, well, all these things, all the pain points we had in delivering that earlier demo, like we need to make better tools, right? We need to make tools to handle world streaming and creation much easier. How do large teams work together on large files? How do we have dynamic worlds that can change with data layers and all that? So a lot of time was spent on workflows and performance and to kind of scale up the creation of those kind of things as well. Then, running into end of 21, we showed off this new demo, which was Matrix Awakens back in the day, where we really wanted to aim to make like large-scale, photorealistic, dynamic worlds, living worlds, where we used Houdini tooling to make this world and make like importers and processors, we call them, to kind of take that Houdini export seamlessly into the engine and all that. And then worked on like a new AI system to kind of run the big simulation of it as well, and many other things. But I think also was important that at that time that this was like peak COVID, and we noticed that the ways we were working was starting to get really different. So we had to invest a lot of time in tools to make workflow improvements for this hybrid setups or even fully remote setups. So Then, we released all this new tech on Fortnite, right? Which is our proving ground always to make sure, like, is it ready for what we call like production ready, right? Can this run at performance, all these platforms? Do we have pipelines to support all that? And that's what we did here. We also made this tooling to make like upres old assets to like nanite quality using kind of pre-baked displacement. And kind of make it all run at 60 hertz on current gen consoles. Then, based on the learning of making that city, right, where we're using Houdini and kind of offline, kind of import-export type pipelines, we started to invest back in the day to work on like a procedural content generation framework to kind of do it inside the engine. Because the thing is, if you have worlds of this quality and this density, you can't render it externally anymore. You have to be in the editor, and also the workflows and the pipelines will become much faster. So we invest a lot in the PGD tooling for the editor, and this was kind of our first showing at that time. We also showcased our new material system, Substrate, very early view on that, and the first release of UEFN. That's kind of the UE toolset inside Fortnite and using Fortnite as a platform. And then recently, probably our biggest release so far in the lifetime, right? Really kind of dumping a lot of new things in there as well. Going from like nanite, improvements with like real-time tessellation and displacement, right? That helps to kind of get much more detail out of smaller assets by just using texture maps. Doing compute and variable rate shading to kind of get the performance up a lot. Lumen with hardware ray tracing, but also excitingly, what you see here, finally we're releasing motion matching to really get the animation quality up. In the past, we always felt that animation in Unreal was not up to par with what we wanted to achieve and with what best-in-class games were doing. And with now the motion matching support that went through a lot of rewrites and all that, we now have a really solid system. And we also released this as a sample for people to play with and test the systems with. And a lot of other things, I think, interestingly enough as well, we internally now shipped games using world partition. So, previously, right, it was always our tech demos and stuff. But now the Lego Fortnite game and Fortnite in the near future will also kind of fully use our world partition, and that's running on all platforms. So, this world partition with many layers and data layers and one file pack, all the things is running on a switch, right? And it's running with PGG enabled to make the Lego game run really well. So this is quite ready for prime time. So that all being said, let's talk about what's coming next. So starting with rendering, and I'd like to kind of go over the aims, right? Well, obviously with rendering, we want to kind of push the state of the art of graphics quality and performance for games on consoles, and support high-end photorealism, not just for games but also for other industries such as film and VFX and architecture and product visualization. It's used everywhere nowadays, but we're going to talk mostly about games today. Starting with nanite. So the big goal of the year for the team is we have full R&D happening on foliage. So the use case is really, right, like think about like a dense forest, up to the horizon. How do you render that efficiently? The problem is that, the polygons are just an aggregation of like little leaves going to the far distance, and nanite is not handling that super well. So we're looking at all kinds of systems to make that perform on like Gen 9 consoles. As part of that as well, we are looking at skeletal mesh support for nanite, which is going to come in experimental mode by 5.5. So you can have like internal hierarchy in it, animate trees, whatever, characters, using nanite, even apply displacement on top of the skinned meshes. So there's going to be like really interesting workflows that you can think of. Nanite for the future, you see that image there. These are one of the directions we are exploring to render far away foliage. Maybe you can think about voxels, right? We are not committed to that approach yet, but these are part of the explorations we have into rendering this at efficient levels in the far distance. Lumen, we have a big effort going into what we call like many lights. So a lot of hundreds of like local lights that are in the world, reflecting, casting shadows and all that. On console, in game, a lot of R&D is going into it, looking pretty promising, but we're not setting any target date yet. Generally, for the future of Lumen, we are both looking at like the high end, like how can we ramp up the quality for some of these use cases and get to like even better fidelity, but also look at making it run faster, because a lot of games are looking to do performance modes, right, running at 120 hertz, 144 hertz, whatever. Can we run Lumen at like sub 2 milliseconds per frame? Is a challenge that we're looking at to pursue. So generally on the rendering area, hardware ray tracing, want to support that out of the box, running at 60 frames per second. We plan to ship Fortnite using that, this year likely. We're working on like path tracer and getting that ready for enterprise and linear content, experimental things there with running it on Linux and those kind of things for big render farms and whatnot. Substrate, we are still in heavy development on that, right? Really the path for us to deliver substrate in a good way is to kind of make Fortnite run on substrate without performance degradation. And then we say like, okay, well, it's not slower than the stuff that we have. And now we can extend the fidelity on top of the base quality with all the new tools. Yeah. And then on architecture level of rendering, right, really the big goal is to enhance rendering parallelization. Really using all the cores and using all the new kind of systems like work graphs and enhanced barriers and stuff like that to make it scale much better over all the cores. Feature-wise, we're also looking at like a new GPU profiler that can support like the modern concepts, just like async compute and MGPU and those kind of things, right? Old profiler didn't do that nicely. We have support coming for bindless resources, which is really exciting to enable kind of much more flexible visuals for artists to add and use various textures across all the other shaders, and looking at like overall improvements in shader permutation and PSO caching and those kind of things by leveraging all these new systems going forward. And a big aspect of all this is that we're looking at a new material editor to really make it much easier for artists to make performant materials out of the box without automatically entering into like a thing that has huge amount of permutations, really slow, everything explodes, etc. So we want to kind of fix that by our new material editor, which is, future, very experimental. Just that we're starting to work on that right now. All right, world building. So this is obviously part of our goal to make like large worlds efficiently with Unreal Engine 5, and have much better workflows, but also have out of the box streaming capability without having to write it all yourselves. So, this is used internally a lot right now, and all the licensees have been jumping on it. So we're making a lot of improvements constantly to performance, workflows, and all those things. And we're also kind of scaling the whole size of the world that we can support up massively. So I think the Lego Fortnite world is on the largest dimension, is like 20 by 20 kilometers now. So that is helped by large world coordinates, by all these new systems, by instancing landscapes, et cetera, which kind of allows us to kind of grow the size of the world. Then with PGG, really the goal again is to kind of keep people in the editor and have people make really rich content by making rules and without having to hand place everything, right? This became really apparent when making a city like this, which you can't do by hand anymore. So that's all runs in the editor right now, but exciting as well is that it's a runtime system. So it doesn't just run in the editor. It can run runtime, it can run at cook, it can run at load time, it can run on the GPU going forward. So this will be a nice system to kind of really kind of beef up the detail across the whole world. And yeah, I think the other thing to mention is that when we are going to like 16 by 16 kilometer plus, right? Who knows how big? And we have millions of actors, maybe tens of thousands per cell that you're streaming in. We're starting to hit a bunch of inefficiencies in like spawn time, load time, etc., that we're hitting constantly. So we're working on optimizing that. Like think about like add to world on like physics and things like that. So with 5, first brief interlude. So this is a good guide. I don't know if you've all seen it. I've been sharing it every time I talk to people. This is our new world building guide. It's like, I don't know, a lot of pages, like 50 pages or something. It runs through all our best practices until 5.4 and shows you how to use all the systems in the best way that we can tell you right now. So please give this to your team, to your tech artists, to your engineers, whatever. So you can find it on dev.epicgames.com. A lot of cool content there. But yeah. All right. So on world building specifically, a lot of work again on like the workflows, customization, quality, and all that. Exciting things like external data layers, right? Not everything is combined in the same object, same level. You can have like different files to kind of contribute to like data layer setups and whatnot. Level instance property overrides are kind of a basic early prefab system. It's not like our scene graph that we're proposing for like UEFN, that we have a prototype of in UEFN, but it is a way to kind of instantiate objects, big accumulated objects, and change things on those instances and kind of build large worlds with lots of buildings and houses and whatnot efficiently. Let's see. Then, sorry, press the wrong button. Then going forward, a lot of work on performance and tooling to make all this stuff work well, right? There's so much data that you're streaming through it, especially if you have like many data layers and many world partitions stacked on top of each other. It's good to have better tooling to kind of understand where things are going and what is loaded and where these issues potentially are coming from. The big thing is towards our new scene graph. And that's really the thing that we've been prototyping in UEFN. That's kind of a full rewrite of our actor component type system that we want to bring back into UE proper. But this is probably a UE6 thing. But you can start seeing what we're doing with that stuff in UEFN. So it's kind of interesting to take a look what's happening there, because you can see about like, okay, if you have this compositional object model, combined with verse, how can you kind of apply that to making games in the future, right? The biggest challenge we have right now is to figure out the backwards compatibility to say like, well, how do we go from UE4 style extra components to like the new scene graph, that's the thing we want to solve, because we want to keep the engine, future versions of the engine, being able to read old content as well. So yeah, PCG, a lot of work going into PCG. We have released like what we call like the biome core. So it's like the first kind of meta system that can handle biomes, so more complex PCG setups to make larger systems. And we're also working towards GPU compute. So the first version of that is coming in 5.5, we're planning. So that means like small PCG graphs can run completely on GPU compute. So really kind of interoperate with Nanite. So they can spawn Nanite meshes completely on the GPU and really get to like much higher detail levels. On the graph execution, that's first getting faster, but also, gives you much more control over where the PCG is running, right? So is it a baking process? Is it running at runtime? Is it running at load? Is it running at the GPU? And trying to figure out if you can find overlaps in computation, right? If you already have calculated it for a faraway LOD, can you use the result of those calculations for lower LODs when you move closer, right? So you don't calculate all the things again, when you're moving to the world, for instance. So a lot of work on that, as well as like interoperate better with spline meshes, Niagara, those kind of things. In the future, I think an exciting thing what we are working on is called Mega Worlds, which is an initiative coming out of the Quixel group. And really, we want to think about like, well, assets should become like smart assets, right? So if you have a tree, maybe it's not just a tree, but a tree knows about the biome it's part of. It knows how to spawn other things around the tree, rocks, bushes, moss, etc. So all these Quixel assets, everything in that library will become like smart assets as part of our Mega Worlds initiative. So we're gonna kind of release kind of various biomes through the next couple of years to kind of showcase how you can make these kind of rich assets. And as examples, right? Because we expect everybody to make their own extensive biomes, etc., using all these tools. So really the goal is for content developers to not have to write PCG graphs themselves, right? Maybe your tech artists are making a PCG graph, but then your environment artists are just placing objects that have embedded PCG graphs, for instance. And then, also kind of more future, landscapes are a big focal area for us. Terrain, you call it. Right now, often the landscapes are, if you look at like Fortnite or something, are the lowest quality geometry on the screen. So we really want to ramp up landscapes to like, nanite level of quality. Without entering like in our kind of previous tech demos in like huge overdraw and really kind of in a nasty type situations again. So we're working on like a completely new system that combines things from full 3D landscapes and height fields and think about everything as like a mesh and all that. So a lot of R&D is going into that. We're working on like first prototypes and all that, but a lot of work going into that. This is probably beyond 2025, but yeah. And man, it's hard to see. Really exciting as well. We have used this in Fortnite since a year or two or something. We have a time of day plugin inside the game or the engine coming. That's using sequencer, so you can use sequencer to make animations on and settings for everything that you can attach to a sequencer to make like really rich time of day visuals. All right, animation. So really our goal here is to push for a full animation authoring pipeline, bypassing the need to use external DCCs. And why are we doing this? Well, the goal is to improve that round tripping time, right? But also what we're finding is, people can actually animate in context in Final Pixel. So if you think about like making a movie where you have lots of explosions and lighting and it's all dark, like why are you animating certain things when they're completely in the dark, when they're completely hidden by all the VFX and all that. So that has been going on for some time. We've been dumping a lot of energy in this, and what's part of this as well is that it's one of our most open and extensible frameworks in the engine. So you can use Python, you can write your own tools on top of this to make like a really custom pipeline for your animators. And ultimately, we'd like to get more people be able to animate quickly inside Unreal. So a lot of areas on animation. On deformers, right? We're enabling that into sequencer and then making that more modular going forward. That whole control rig and modular control rig where you can like easily make components and attachments and dynamics on a skeleton. That's now moving to beta. And that will, in the future, get a lot of work with interoperability with physics and deformer graph and skeletal editor kind of improvements in that realm. The skeletal mesh editing was this missing aspect of the engine where you still had to use an external tool for that. So that's now completely built into the Unreal editor and quite capable. And we also have like a lot of work going on to like retargeting, where you can move these animations across different style assets and kind of keep the movement of the feet and all that in check. Then last but not least on this one, ML Deformer has been getting constant updates, right? It's a really powerful system, and I don't see a lot of people using it yet, but it's really performant, right? It is running on Fortnite. We have it on various characters, and it's running like sub-millisecond on full muscle sim kind of output on like the Hulk character and stuff like that. It's really cool to look at, and it's one of these nice use cases for ML, where you train a simulation with like hugely complex simulation and kind of output into a really simple model that you can run in runtime. And much more of this is completely able to run inside the editor, so you don't need full muscle sims or simulation tooling in external tools anymore. On sequencer, so sequencer is getting a bunch of love, especially in like the UX area, right? We really want to aim to broaden the appeal of sequencer across the editor, making it more clean to use, but also we are seeing it being used for kind of any of the timeline tools inside the editor. So you'll see sequencer pop up in more and more areas. We have a effort called dynamic sequencer that we plan to use that to extend a sequencer to more dynamic operations to basically make interactive cutscenes easier, right? So go from your game to a sequence more seamlessly without having to do a lot of hacky effort right now. And really that kind of runs into our kind of future efforts into like a cinematic dialogue system. So can we make a basic dialogue system, branching dialogue system in the future that's as kind of part of the engine that you can all extend, obviously. a purely animation in the engine, like really, for the animator. A lot of work has been going into that, animations layers, and also we're getting this focused animation mode, which is kind of exciting because we want to switch the UI of the editor because it's getting complex again, to be more focused around the persona that's using the editor for a certain purpose. So animation will hide a lot of things and kind of focus on animation. Also what's probably interesting to mention is for Lego Fortnite, for all our Fortnite cutscenes, and now also starting to run in Fortnite itself, we're all using this internally. So all our animators at Epic are using this tooling to make all the animations. Right, for Lego Fortnite, we have not used anything but Unreal to animate all of this stuff. So that's great because we have a lot of animators screaming at the programmers to make the tools better. This is terrible. Like, please, this, and we make a lot of progress that way, right? So that's now all in 5.4 and further 5.5. So yeah, motion matching. Really happy that we are now releasing this, we have released a sample. Obviously these are complex systems that only run with a huge amount of data, so you can only evaluate it when you have a huge amount of data. So we have hundreds, I don't know how many, crazy amounts of animations as a base version for you to test the system with. And you can use them as kind of your base layer and then start layering things on top of that, but also say like, well, this is actually working really well for our type of game. Maybe now we can mocap this ourselves and clean it up ourselves to have a more unique set, because I'm sure not everybody wants to use the same animation as we do. But we actually use this for Fortnite as well and kind of made like a stylization pass on top of that to kind of turn it into Fortnite animations, but it's using the same underlying animation mocap data, actually. And we're expanding that a lot, right? The team is continuing to work on like multi-actor support, tooling around picking the right trajectories and such things as well. Then on the systems side of animation, previously we talked about like the tooling. Now we're talking about like more of the gameplay systems side. We're working on this new gameplay camera system to really help, interpolating between like gameplay and cutscene kind of cameras, alongside with giving debugging options, like to make that happen easier. A lot of work on like various debugging things, right? That's again, right? We have people internally using this, that have problems. Like, how do we debug this stuff? So we have to improve these toolings around a debugger. So you now can save and load the state of your full animation diagram and setup, but also kind of connect to a console to see what is happening. Why are certain animations being picked? Why are the blends in the blending like the way, and scrub through that, which is quite amazing. And mutable, we're also getting the mutable middleware that we have acquired a couple of years ago as part of the engine. So that means you can use mutable to make customized characters easy and make it as an integral part of the engine going forward. This also improves cook performance and support content on demand with mutable. So, and then future on systems, we have an effort that we call Anim Next internally. We'll probably get a better name the moment we actually productize that. But really, this is a way to make a new kind of unified animation pipeline where we want to make the animation graph logic much faster by leveraging all the work we've been doing on the rig VM for control rig. So we want to run all these things on the same hyper efficient VM that we built for control rig and kind of integrate all those things. So we plan to run all our next generation logic on that, and then we expect to not have to nativize animation graphs anymore. Right now, that's that graph. I don't know if you can see it, but Blueprint right now gets really slow. if you have complex animation graphs with RigVM, I think we can get it to at least 5 times faster, maybe 10 times faster. At some point, it doesn't require you to nativize it anymore. So. Okay, then on developer iteration, so a lot of work going into that, right? Games are ever expanding in size, complexity, data, etc. Teams, we hope for them to make games faster and iterate more, which ultimately gets to better quality. Exciting that we have Unreal Build Accelerator now supporting shaders, but also Windows, Mac, and Linux coming with 5.5. We have Horde CI coming into production readiness, so that's cool to run all your continuous integration, right? Horde does much more than continuous integration, but this is the part of Horde that does that. And we also have a new thing which you call the UE Studio Telemetry, that you can hook in all your tools, all the Horde and UBA and editor stuff, etc., into a kind of a telemetry pipeline that you can hook up to your own telemetry backends and kind of show developer efficiency, crashes, spot trends in like cook time and load times and editor stability and whatnot. So, yeah. On the editor and target iteration, we have a lot of work going into all these various things. Like Zen Loader is really kind of optimize loading in the game, but also in the editor. So can we get the startup time of the editor much faster by async loading things without having to read through all the world partition stuff? Shared DDC and cloud DDC and those kind of things, and cooked output store is really about like, well, if some person on your network, on your team transformed an asset or cooked an asset, whatever, can we leverage that effort to the entire team, so you don't have to do that work double? And then, a bunch of other things. I think also important, the Zen target platform streaming. So, for the longest time, Unreal was really efficient in a PI setup, right? So you're on your PC, going into PI, going back, etc. But really running it on a target device or a console, it was not great. And we're trying to fix that with the target platform streaming, where you don't have to package and cook and make monolithic kind of things that you copy to your dev kit, but really you stream it from the editor, from all these toolings that we have directly to the target platform. Yeah, and then down the line, we do want to have a big rethink of like how we cook, etc. We are digging down into making incremental cooking instead of iterative cooking the default. So that will improve a lot of the speed there. But also looking at like, well, can we have like cooked editor support out of the box for a UE? All right, cool. Simulation, and I'm starting to run out of time, so I'll kind of have to accelerate a bit. Simulation, both physics and particle effects. A lot of improvements coming there with physics. We have the most exciting things perhaps is talk about like the ML Flash. We're expanding that a lot. A lot of this stuff is going to run completely in the editor going forward, so you can have full musculoskeletal setups right in the editor that can run on any metahuman. So they have full deformation running ML Deformer, etc. We have the Chaos Visual Debugger coming online in 5.5, which is really exciting to kind of actually see where things are going. And generally we're working a lot of performance right across the board to help even more complex things. Niagara, a lot of things in flight. A bunch of things going into production ready with data channels and lightweight emitters that are really interesting. Stateless emitters coming down in the future. But also looking at like improved iteration time in like the editor and the cook aspects of it. Performance. Can you run these things at frame rate on devices and all that? And looking at like things like running nanite particle renderers and those kind of things. And then a lot more work in like performance and interoperability and all those things. And I think you start to see the benefit of having like our own physics engine and our own advanced VFX system and PGG starting to kind of interoperate and kind of get to much more capabilities when they all are working together seamlessly. Then framework, so that's gameplay, AI, and networking. So a lot of work going into 2 areas, like really like workflow improvements, right? Like can we make it easier to use, inputs, new movers, gas modularization, state tree, and all that. But also performance, right? So much more lightweight actors, mass gets extra functionality, instancing by default, so everything is an instance instead of just an actor